Hi everyone. In this lecture, we will discuss about Word2Vec and its importance. So the Word2Vec actually it introduced by Google in 2013, and it is a one of the popular word embeddings in the NLP space, right? And so the every word it is projected into a continuous space. When I say the every word into a continuous space, right? So the every word has its own vector dimensions, right? So which is very popular, and it is a fixed length actually, right? When I say fixed length, that can be decided by using the cross validation. So either it is 100 or a 200 or a 300. So the usually the word embeddings usually from 100 to 300. So that can be decided through a cross validation technique. And then initially there are a lot of pre-trained models are also available in the Word2Vec space. So this is one of the very popular in terms of the pre-training models as well. So they are learned from a very large corpora, including the Google, Wikipedia, news channels, and then we have a web pages and many more, right? So they can be even customized if you want to develop your own Word2Vec model in terms of any specific domain, right? So that can also be done in the Word2Vec space, right? And most important thing is it is based on a concept that the similar context words need to have a similar embeddings, right? So and then if you have a different context, they should be completely different space in terms of the embedding space. So we will discuss about different type of Word2Vec models. So we have a two type of models in Word2Vec. So one is the skipgram. The other one is the continuous bag of words. So CBOW we call in short, continuous bag of words. The other one is the skipgram. So here the skipgram is ideally we predict the context from a target word. So in the continuous bag of words, that's a reverse. So predicting target word given a context. So this is majorly the difference between the continuous bag of words versus the skipgram approach. So we will illustrate with one example. So here the example is she loves to read books in her free time. She loves to read books in her free time, right? So now we make the training data from this sentence both for skipgram and continuous bag of words. Example, now let's say think of we are building a word vector for the books. Okay, so this is a target word you can think of, right? So the target word is the books. And now we have a hyperparameter which is called as a window size. So that window size we need to consider the left and right together. So if let's say if window size is 3 we are considering, then the left side 3, right side 3 words. And if we are considering 2, then if left side 2, right side 2. That's how the window size defines. So now let's say think of for the window size 3, window size, this is an hyperparameter, you can tweak this. So now, so window size when we consider 3, we go back to from the target word 3 previous words, 3 next words. So that's how we consider. So this is how the window should be. So now let's make the training data how it look like in skipgram and CBOW. So in the skipgram, if you take x and then we have y dependent variable, right? And predicting the context from a target word, right? So hence this will become your independent variable, which is books. Books will become at every example books, and then y is allows. Similarly, books, then two, then books, then read, then books. We have in books. So in the continuous bag of words, the x and y will become predicting a target word given a context word, right? So hence loves to read, then in her free. So this will become your x independent variable, and then everywhere now books will be a target. So this is how training data will look like in a skipgram and a continuous bag of words. So now in a skipgram and continuous bag of words, right? So which is a better in terms of defining the approach, right? Usually the most popular method in the traditionally in the Word2Vec is the skipgram, because of it is a better in understanding the rare words, because we are trying to predict from the given target word the context, right? So hence you will also have the word embeddings for the rare words as well here in the skipgram. But here in the continuous bag of words, you are predicting from either rare words or the frequent words. With that, you are predicting the root, the target word, right? So it will be averaged out. Like if you are printing the embeddings for the rare word, then whatever the context vectors that is defined for that particular rare word, so that will be averaged out. That is why it will not be able to represent the rare words, but it is represents the rare words, the skipgram approach. But one disadvantage of skipgram is it is little complex compared to this continuous bag of words. It takes a little more time comparison with the continuous bag of words. So continuous bag of words is really a simple one, and it is a quick solution, but it doesn't represent you in terms of the rare representation of the words, right? But in skipgram, little more complex, because you are trying to predict from a target word itself a lot of context. Like if you have a window size is 15, so this side 15 and that side 15, so we have the total 30 words to predict, so it has to learn a lot of patterns, right? So it is a little tedious in terms of the complexity, but it gives you a better representation when you compare with the continuous bag of words approach.